Okay, on 22, I just want to show you some instances where an equation in standard form might not be the best choice. So, for instance, I got 3 different problems here. So, number 1, what if I give you negative 3x plus 5y equals 5? So since this is in standard form, you might say, okay, that cover-up method worked well for graphing a line. So let's pretend I have to graph this line. All right, so if I have to graph the line, I'm going to cover up the 5y and pretend I put 0 in for y. So I see negative 3x equals 5. So the problem here is when you divide by negative 3, you find out your x-intercept is negative 5/3, which is a fraction. When you get a fraction with this, you have to choose a different method if you're going to graph it. So this intercept method, or cover-up method, intercept method, same idea, does not work in this one. So in this case, you should solve for y if you're going to graph. So now let's try the problem again. Negative 3x plus 5y equals 5. And now, if I'm going to solve for y and get it into slope-intercept form, I'm going to add 3x to both sides. So 5y equals 3x plus 5. And then divide everything by 5, each term. So y equals 3/5 x plus 1. And that equation I can graph in y equals mx plus b form. All right, another case where this might not work. Case number 2. Case number 2, x plus 2y is equal to 0. Okay, if you have this equation, and I tried cover-up method since it's in standard form, I cover this up, I see x equals 0. All right, all is good there, so my x-intercept would be 0, right here. Now I cover up the x term, and I see 2y equals 0. Divide both sides by 2, y equals 0. Y equals 0. Okay, well y equals 0 is the same dot. I need 2 dots to make the equation of a line. So is it going to work? No. They're the same intercept, so you only have 1 dot. You need 2 dots to make an equation of a line. So this is a case where you would have to solve for y. And you would do it just as we did up above. And then you could graph it. All right, and then the last one, the third situation, 2x minus 3y equals 12. So this is a case when again, it's in standard form. I try the cover-up method. I see 2x is equal to 12. So therefore, x is equal to 6. So that one is good. I see negative 3y is equal to 12. Divide both sides by negative 3, y equals negative 4. That one is good. I have 2 different x and y, 2 different intercepts. So this one I can make a graph for, and I could go straight to that. So just a note, you can always find the x and y intercepts, but sometimes they are not useful for graphing lines. Okay, and there